Hello, and welcome to another episode of Everything Digital Health with me, Marcus Bohr. I've been working on a couple of projects over the past few months that I will bring to the channel in videos over the next few weeks, really. Been very busy and working on some quite exciting stuff. This episode, I'm going to talk about something I've actually been working on in some form for more than 10 years. And it's an idea that came to me when I started to go to NHS Hack Days and started to get involved in seeing what developers did. And you find out about things like Markdown, which is a simple text format that's used for giving HTML-like structured data attributes to kind of a plain text file. So it allows you to write something quite quickly in plain text and give it markup as you go, using little additional characters like a hash sign or something to delineate where the headings go and things like that. And then you can turn that into HTML pages. And when I saw this, I thought, well, that's great. Maybe we could do something like that to turn free text medical records into structured data, because that's something that we always need. You know, we as inputting clinicians increasingly want to write some narrative text, and you don't want to have to keep clicking in and out of different input boxes to do that. You want just one big input box, you put everything in there, and the computer should be able to work out what your structured data is and where it should go and what it means. So this is a kind of an old idea. It's not anything incredibly revolutionary, but at the time, I wasn't capable of programming any of this stuff. And so a friend of mine, Ross Jones, who I'm very grateful to, he originally coded up a kind of Python prototype of this. And so we have that, we've had that as a repository for over 10 years. But more recently, because I've been using a lot of Rust, I decided I would rebuild it and use Rust to do that. So we've got a much faster, simpler engine that doesn't have any sort of external dependencies, and it can even run in a browser using WebAssembly. So we've got the state of the art has moved on and has enabled this to be quite cool. So let's I'll go and walk you through the idea. It's not gonna change the world, but I'm just interested to show you all, really. So this is Medical Markdown. It's a kind of Markdown related specification, and it's a work in progress. So it's not something that you could necessarily go and take and put into production right away, but it's not far off, actually. If there was interest in taking this forward, and certainly if I get any feedback from the community, because I think that's what this idea really needs, is some sort of challenge and sort of work out where it fits in, then absolutely I would be able to get this to production within weeks, really. So the repository started off as really just me describing the specification, and so I thought, where better to do that than in a place that's on the public internet. So I whacked it all in a GitHub repository. But now we've actually got code in here, and it does actually work. So if that's for the people who kind of want to read more about it. Quick diversion to explain a little bit more about what Markdown is, because I'm aware that not everybody who will be watching this is familiar. Markdown was specified by John Gruber, otherwise known as Daring Fireball, back over 20 years ago, as a way of making text that you could convert to HTML. So if you're a writer and you want to write stuff, but you want to have the structure that comes with HTML, headings and bulleted lists and things like that, you want to use links, you want to use bold, you want to use italics, footnotes, all of that stuff. If you had to type all the HTML for that, which is perfectly possible, it just slows you down and it takes you out of the writing flow to sort of mark things up. And the pursuit of that led him to come up with this Markdown specification. And actually there's a really nice footnote here where he attributes Aaron Swartz, who is one of the sort of founding the internet's own boy, as he's described in the biopic about him, and he's credited for a lot of feedback and helping to make Markdown what it is. But the basics of it are that you can have, if you write some text in plain text and put some equal signs underneath it, it will interpret that as a header. You can do the same thing with a minus sign and it will be a slightly less, it will be a second level header. And you can see what this allows you to do. It means you can just type and it already looks, even in text form, you can see what the structure of the document is going to be, but then you will, when it's been output, it will output it as HTML with the right tags on it. And this is all, you know, starting to sound a little bit technical, but I assure you it is a very user-friendly way of getting information down if you're having to type it. I know that we live in a world in which ambient voice technologies are threatening to take over all of the typing, but I don't think that that's actually going to completely replace the need for us to interact with medical records using a keyboard. Not entirely and not immediately. So there'll always be a balance of, you know, some of the stuff that we have to put in by hand and some of the stuff that might be dictatable. But there is a guide called the Markdown Guide. So if you want to go and have a look there to learn a bit more about Markdown. And I also wanted to kind of try and illustrate the point of what I'm trying to replace here, which is that medical records quite often have numerous input boxes. So the presenting complaint goes in one input box. The history of presenting complaint goes in another input box, because this is what a developer will do by default. If you tell them these pieces of information have to be gathered separately because we handle them separately, they'll say, well, that's a field, that's a field, that's a field. You end up with a web form. And, you know, I tried to find a good example of that on Google on an image search and actually couldn't, because one of the things about EPRs is that they don't tend to put an awful lot of screenshots online, so you can't generally find anything. The nearest I got was probably not necessarily a medical interface. I mean, this one, it does talk about allergies, insurance. You can see what's happened here, that it's everything is a field, but I couldn't quite find anything that illustrates this in a kind of clerking scenario. So I'm imagining I've been to see the patient in ED, I've come back to my computer and I want to just quickly write down what I found. So this is what you would do in Medical Markdown. So this is the repository I just showed you has a live demo built into it, so you can just go and look at that. And what I've done, I'm kind of simulating going through a quick A&E consultation. And on the left is the Markdown that I'm writing, and on the right is the structured data which it is extracting. And it's doing that by hooking onto the little clues that I've put. So PC means presenting complaint, HPC means history of presenting complaint, past medical history, drug history. So these are all things that we get taught in medical school, and we are quite happy to sort of use a piece of paper and write them down. But the advent of computers just destroyed all that and meant that we are now at the mercy of the developers of whatever EPR we have to use. And that might not use this structure. It might use a different one. And crucially, the real crime here is that they all use a different one. I think if there'd been some coordination and we'd managed to get, if for example, the PRSB and the Royal College of Physicians had managed to make their sort of headings approach to these things actually land in the industry instead of just writing reports about it, then we would have a ubiquitous and standardized clinical user interface, and I think that would be fine. But we don't. We're a long way from a ubiquitous and standardized clinical user interface, which is why I spend my spare time doing shit like this. Anyway, let's start entering stuff. So you see, I wrote chest pain, worse on exertion. It knows that anything after PC / is presenting complaint. So we're getting structured data presented to us in a nice way on the right hand side. So as I start to kind of unhide all this text, I'm not typing it in real time just for the sake of the demo, but you can see, there we go. We've got a history of presenting complaint. Obviously, you go into more detail. That's a bit more detail. Then you pass medical history, hypertension. This is a kind of standard chest pain, exertional chest pain you'd see in A&E. But what we're doing here, although I've only had to type in one text box on the left, it is separating it out automatically into the right-hand side. And these delimiters that say what bits are what, they're not set in stone. They potentially could be anything, but I think the important thing is they should be standardized. we've got no known drug allergies. You can only imagine, like, if we added support for structured data technologies like FHIR or openEHR to this, that would be entirely possible, very, very easy to do. And you could also include terminologies. So, for example, where we've got a drug dictionary, we can include metformin 500 milligrams BD and do a lookup, find out what we mean, and make sure that that's represented. So actually, as part of just typing all this in, we're getting intelligent, deterministic spell checking by checking that we haven't misspelt metformin because it comes up as a VMP. We can check SNOMED for like what is an appropriate entry for an allergy, for example. I mean, you couldn't do that with free text, but you can do it once you start to know a little bit about the meaning, and you get the meaning from these headings. So that gets us to a point where, we can enter an examination, and this is all, standard stuff. Nobody in the medical profession would be looking at this and saying, I have no idea what's going on. This makes complete sense. And we've got a plan. So, you could imagine that this part, now it knows we're in the plan. If I start typing drugs, it could say, do you want to prescribe this drug? Then it could guide me towards, a formulary of things that I'm allowed to prescribe in this setting based on things I've already entered, based on a hospital formulary or whatever. So we could make this into a very, very neat user interface that does all the structured data things that we need out of an EPR as well, to help to guide the clinician to the right treatment, to keep them away from danger areas, and to allow things like searching and indexing and research and audit and things. You need the structured data for that. You can't just do it over a bunch of free text. Just to show you what's happening in the background, the engine that's behind this, very simple pattern matching text engine, just says, well, if it's PC, then the notes for PC are the bit that comes after that. So that was chest pain. So we know that the presenting complaint was this. We could have gone a bit further and said, right, put a SNOMED code in there. So now we know what the presenting complaint was. We might want to put SNOMED codes in the differential diagnosis, but we'd certainly want to, the impression might be SNOMED codable and might be very different from what they presented with, if you see what I mean. All of this just makes it really easy to do. So it's just an idea, really. It does work. I'd love to see what people think of this. I think it needs some feedback from the community to see what we can make of this. But I think if there are other people who like this idea, it is free and open source and permissively licensed, I think. It doesn't yet have a license. It will be permissively licensed by this afternoon. But essentially, the idea is I want people to be able to take this and without any, there's no cost and no sort of licensing encumbrances, to take it and use it in an idea, in an EPR interface. So please do take a look at Medical Markdown and let me know what you think. I've really enjoyed this last few months where I've been a little bit freer of time for reasons which I will be able to share with you in a couple of weeks. And it's actually given me a load of time to work on some brilliant projects. So things like Medical Markdown that have just sat in a GitHub repo for 10 years. Suddenly I pulled them out of the closet and said, right, okay, get in there. Let's write a specification for what this is. Let's write a roadmap. Let's make it better. Let's turn it into something that's really fast and performant and cross-platform, and starting to do all the things that we couldn't do because of just lack of time and the length of time it takes to code something. And also, essentially, re-platforming it in Rust has enabled me to sort of make it something that can just run anywhere. So that if you've got that binary for your architecture, you can just run it. As opposed to Python, which required a Python runtime, it's a bit slower. All of those things are baggage that you don't necessarily want with something low level and simple like this. So I hope you've enjoyed that. I've been building a lot of low-level and simple tools. I have showcased some of them already to you. So SCT, which was my SNOMED toolset that came out in April, and that's due an update because I've done a lot on that, and it's now its own fully featured terminology server. It's been benchmarked against other terminology servers that are available, and it's very fast. So there's going to be a bit of an update on that, but I've got half a dozen other projects that I need to show you. So hold on to your hats.